All right, guys. So we are just getting started and exploring quadratics. Like I said, we've got a lot of time in this unit, so we're going to get a little fancy and just learn the little ins and outs as we go. That way we make life a little bit easier later on in the unit because we are familiar with kind of the building blocks, if you will. All right. So we're going to be talking about the quadratics today as it pertains to their shape, kind of forming a mental image and being able to sketch it, just based on looking at the equation. Okay. So we're going to start with the equation. Let's talk about that for just a second. Let me get my windows kind of where I need them so I can see everything I need to see. Sorry. Bear with me. Right. No, we look good. I feel good. All right. Okay. Okay. So let's talk, right? Quadratics. We'll say this today is quadratics 101. Because we're basically going to talk about the basics. All right. So first thing first, right? We should know standard form. That is a must. We've got to know it. We gotta memorize it. It's got to be there at a moment's notice. Okay. And so standard form is the y equals ax squared plus bx plus c. Okay, that's a given. Standard form, always going to be. We always identify the a, right, as the leading position with the x squared. B is here, and then c, we should have discovered yesterday, is our y-intercept. Okay. And that's important because as we want to sketch graphs and visualize kind of these graphs, we got to know where different pieces are. Okay. And so we have basically two different types of parabolas. So we have types. Now, what you'll have to remember is that parabolas are always symmetrical. Okay, so when we look at the two different types of parabolas, okay, now they can be anywhere on the graph and they can touch those, but what we need to know is that, right, they're always symmetrical. So as symmetrical as we can draw them, at least. All right. So there's our two types. Well, what do you notice about the two types? And well, you should notice, right? One is facing up, right? One is facing down. Okay. And no, we don't call them happy and sad academically, right? That's not what we say. But it is kind of how I describe them because it helps us link to the academic side. Okay. The happy guy, well, he's always upbeat. Okay. And so we always say it opens up. Well, and the sad guy, well, he's always down and out. So he opens down. Okay. He's just sad guy. All right. So opens up and opens down. Right. That's how we're going to talk about these. Okay. We're opening. Our opening is to the up, right? All of our data is up here. This one is going to be, right, sad. It's opening down. All right. Now, how do I know? How do I recognize this just from looking at the equation? Okay. And maybe you made this connection yesterday, and maybe you didn't, and it's okay if you didn't. Okay. If A is positive, you will have a happy parabola, okay? Positive people are usually happy people, okay? Whereas, right, if A is negative. And so as you look at all of your different examples from yesterday, hopefully you saw that trend, right? If the leading term is negative in your standard form, right? If your A value is negative, you're going to be opening down. If you're positive, you're going to be opening up. Okay. Every time works. You can try it as many times as you want to. Okay. So there's two types, right? The parabolas. You have a happy and a sad one. It either opens up or down based on A being positive or A being negative. All right. And then the next thing we have to talk about is the vertex. And the vertex can be one of two things, right? What is it? Well, it's the turning point. But what can it be? Well, it can be what's called a minimum, which is the lowest point. This will occur in your happy parabolas, right? Or a maximum, which is the highest point. And that's going to occur in your sad parabolas, right? Because, right, he can only get so high up and then he's got to turn around and go back down. And that makes him sad, right? He can't get as high as his other one, right? This guy, well, he's going to have to come down a little bit, but then he knows eventually, well, he gets to start traveling back up. So that makes him real happy. All right. So vertex, real easy, right? It's the minimum or the maximum. Well, right, how does that help us knowing what the minimum and maximum is? And what if I can't, how do I get that, right? What's an easy way to get that? And that's the point of today's kind of video, is to talk about this guy, okay? The axis of symmetry. Because all parabolas are symmetrical, okay? So they're all going to follow kind of a mirrored image of itself. If you were to cut it in half, you could fold it over onto itself, okay? So the axis of symmetry divides the parabola I went all wrong with that one. The parabola into two equal parts. All right, so axis of symmetry is going to cut it right down the middle. Okay, so it's either cutting a happy one in half, where you can fold the two up arrows directly over on each other, or cutting a sad one in half and you can form the two down arrows right on each other. Okay, now there's the beauty to it, is we're going to use this knowledge to find our vertex out of thin air without having to graph at all. Okay, so our axis of symmetry runs through the vertex. Okay, and this is a very important knowledge here. The axis of symmetry runs through the vertex, because if you think about any one of these, if I was to cut it in half with an imaginary line, right, it's to be directly in half, it's got to hit right at that bottom, okay, at the minimum, whereas this one, it's got to come down, cut this one in half. Well, it's going to hit at the maximum. Okay, so it's always your axis of symmetry will always run through the vertex. And so being able to pull the axis of symmetry out of thin air is going to allow me to then state my vertex very easily. Okay. All right. So how do I get the axis of symmetry out of thin air? Okay. First, you're going to need to know the formula, right? And it's a very easy one. X equals negative b over 2a. Okay, that's our formula. Well, where do all these letters come from? Well, they come from the standard version, right? And why do I want to know x, right? I thought it was y equal. Well, what we're essentially going to do is create, okay, so you find the x value for your vertex point x comma y. Okay, you find the x value. Why we find the axis of symmetry using this formula? Well, this is just a line. This is a vertical line. It's an x equals line at this number. And once I know that, then I know where my vertex is going to be. Okay. And I'll show you through an example. It's a little easier once we follow along. All right, but we'll give you a second to write that down. Okay, so let's look at an example. Okay, so keep in mind, we're just sketching these. We don't have a graph, right? But this is our equation. So example 1 is going to be y equals x squared plus 8x plus 15. Okay, so I can already tell you a lot about this without even graphing it, without typing in my calculator, just by looking at it. Okay, number one, I can tell you that the y-intercept is at 15. All right, so it's way up there on the y-axis, right? It's at 15. I can also tell you that this one opens up, right? So I can look right here and tell you it opens up. Okay, so just as a mental note, don't know, like this is what I'm envisioning without ever having done any math, right? That's kind of what I'm looking at, something like that. I don't know, maybe not, maybe I'm completely wrong. Maybe it's over here, right? And it goes like that. I don't know. But I do know it opens up, right? And it's got a vertex or y-intercept right there at 15. Okay. I know that. Okay. So that's where we're at. It could be up here, right? It could do like that. Could open up there. What I do know, though, is it does not do this, right? It does not go like that. That's incorrect. Okay. So all of these things I know just by looking at that. Okay. So, but again, right, we can ignore that. All right. Okay. So let's actually use our vertex formula. Our vertex formula says, right, to find the axis of symmetry, I say our vertex formula, it's really our axis of symmetry. I know the vertex is going to be at a certain point. And so let's find the x value by using the axis of symmetry. So I've got negative b over 2a. All right. Negative b over 2. Now, first thing, negative b. That means opposite. Now, this one is a positive 8, so it's going to be negative 8. Negative 8 over 2a. Well, a is a 1, right? There's that imaginary 1 right there. So 2 times 1, which means the x value for my axis of symmetry is negative 4. Or the vertex is negative 4. Okay, so I was wrong, right? I can draw this out. And I know there's a y-intercept way up here at 15. Somewhere, if I was to plot this out, okay, out to -4. Right, so it goes like that. Right, if I go to -4, 1, 2, 3, 4, my graph, and I'm dotting it because it's imaginary, my graph is symmetrical about this line. So if it comes down right here to say right here, well, then it's going to start going up the same this way, right? If it comes down way down here and then bounces up, well, it's going to do the same, right? But I don't know where. I've got to figure that out. Well, that's where this is. Remember, this is an X value. Since I have an X, I can find a Y by simply plugging it in, right? So using -4, I'm going to put it in. Okay, so -4 squared plus 8 times -4 plus 15. Right, so I've got 16 minus 32 plus 15. 16 minus 32 is -16. -16 plus 15 is -1. Okay, so -1 is my result. So y equals, right? All the way down as I work it. Okay, y equals -1 when x is -4. So that is going to be my vertex right down here, right about there. And, right, we are symmetrical about that. So we're going to come down, and that's my lowest point. We're going to hit, we're going to go back up. And there's the sketch of my graph. Now, is it absolutely perfect? No, but it doesn't need to be, right? I know that that's a rough sketch of this graph. And without a doubt, that's what it's got to look like. It's got to open up. It has a minimum value at -4, -1, a y-intercept at 0, 15. Okay, and an axis of symmetry right here at -4. All of those things I know without really having a solid graph. Okay, and it's just by knowing some different little parts. All right, so we're going to do one more just to give us some practice, just to see if we've kind of caught on. Let's pick a different one that's a little bit fun. Sure, I like that. Okay, so, and Nadine made this observation the other day, and I liked it. She did a good job catching it right up front. She's actually made 2 good observations, but I'm only going to let you in on one. Can't give away all the secrets on day 1. So we have y equals -x squared plus 4x. Okay. That was this is going to be our graph. So what do we know? Well, I can visualize this one as opening in which direction? And hopefully you would have said down, right? We have a negative a value here. What's a -1? Remember, it's always understood to be there. Okay, so I know it's opening down. I also know something else, right? What is the y-intercept? And hopefully you said 0. Okay, so no matter what, that point is a good point on this graph. Now, from there, I don't know. I don't know what else happens. What I do know is it goes through that point. So in order to find, again, the vertex, I need an x and a y. And in order to do that, I'm going to use the axis of symmetry. That is, again, x equals -b over 2a. Again, this is opposite b. In this case, it's a +4. So it now becomes a -4 over 2 times -1. So that's -4 divided by -2. And so I get x equals 2. Right. So if x is 2, right, and that goes right there, okay, that is 2. Then how do I find, right, my other y value? Well, I put it in. Okay, so y equals -2 squared plus 4 times 2. Now that is a -1 right? Imaginary -1 times 2 squared. It's not -2 squared. It's different, right? -2 squared would be +4. And in this case, this should be a -4 because it's 2 squared times -1 plus 8. So 4. All right. So 2, 4 is my vertex. So roughly 2 and 4 looks about right there. I know it opens down. So it goes like that and like that. Okay. Rough sketch, but that's what it looks like, right? And we have that symmetrical or symmetry about that imaginary line. And that's it, right? That's really all we're doing today. I want you to get a visual picture based on kind of some really easy things to grab, right? We don't need a calculator for all of this. Now, can we use one? Absolutely. Are we going to? Yes. Okay, but right now, all I want you to do is just be able to look at it, glance at it, and see what does it look like. Okay, so I have included some practice for you, just sketching. And all I want you to do is see, basically, can you pick out when it opens up and down? And then sketch a rough graph. All right. Any questions, comments, or concerns, guys? Reach out, shoot me a message, and we'll get back to you. Thanks, guys.